is pure or not. Some simple technique. Because in those days you didn't have spectroscopies, CV, this and that. Water? But Eureka was there. Okay? And he was just running with no dress on. People say in those days. Next slide, please. Okay, and the previous one. Now, what he thought of was the density of gold. The used one, initial one, should remain the same, isn't it? Even after and before. So, what he did was, while he was doing that particular experiment, his mind was thinking that I am an object, so I am just immersing to some extent. The volume of my body is displacing equal volume of water out. He weighed that, weight known, just the purity of gold. And remember, if he failed to do this, Archimedes, he would have lost his head. So science has helped to save the heads of scientists. That is one. Now, here is what I say, the intelligence of Archimedes, because of his open mind, the smart mind was able to grasp the opportunity, because he was observing. So you must be very keen in your observation, and the brain should work on this, why it is happening. Ask why this is happening, what is happening, how it is happening. When you ask how, you get the mechanism, why it is happening, you see the reason behind. So something like this, the scientific principles are developing. Next. Now some of the quotations about this serendipity, very great people have said in so many words, same thing, old wine in new bottles. See, you must have a very smart mind. It's only accidental discovery. So if you are alert, you will be able to pick up the discovery. Next one please. Thus, you get by surprise. Surprisingly you get new things. And your mind is alert to find that. So that kind of a new discovery helps you to develop science. That is the need for serendipity. If you stumble upon some new discoveries, maybe you are filling a gap in the scientific development. And then the latest, or if you look at the whole of serendipitous discoveries, most of them are from chemistry. Why? Because in chemistry we talk about transformations within chemicals, isn't it? When physics talks about the study of matter, their properties, here we talk about the transformations. How to make one element from another, because in those days we used to talk about carbon as an insulator when it has the sp3 hybridization and 4 valencies, but in graphite you have sp2 and so on, planar structure. So the structure is conducive with the delocalization of electrons, which is causing your conductivity. But in those days, when this knowledge was not available, he was the first man to find out what? The conductivity, serendipitously, very important. And one example here is the discovery of carbon dioxide, because he was doing some experiments with candles, and when he had some gas, without knowing it was carbon dioxide, he had some sodium bicarbonate and some natural acid, fatty acid was there, slowly carbon dioxide was there. He was wondering what is the gas, and he put some mouse inside a closed vessel. The mouse died. And after that he repeated the experiment with some plants inside water. He put some bicarbonate, this chamber containing this gas. Now it was very brisk. So naturally this would be a different gas, isn't it? Because in one of the gases, this carbon dioxide, it died because there is no oxygen there. That is how you have to look at it. You have to look at what is the fact behind it. So when you do some mistake, just look at what it is worth. That it is something new. So always the mind should have the positive attitude. Rubber was also discovered by him using neoprene. That is also accidental discovery. But there was one very sad story about this fellow. He was full of negative attitude. So he thought, okay, I am toiling and moiling in my lab. I am not becoming a very great scientist. I am not able to earn money. So, out of rejection, He committed suicide after making two serendipitous discoveries. After his death, what is the use of that? People knew that he has discovered two new polymers. Had he had the positive attitude, he would have stayed back on this earth. He would have made more discoveries. So serendipitous, what? Discoveries he would have made. And that is a sad story about this. I chose this one because all of you must have a positive attitude as a chemist or a scientist. Next one. Similarly, the polyester, here also there was an experiment. They were doing some polyamides initially, and the property was not to their taste, so they wanted to do some polyester, and the polymer was not there initially, and one time there was a small test tube, it was just falling, there was a glass rod, they were trying to remove the glass rod, it was sticking there inside, while they were removing, it came off, it was coming. What happened? There was a long molecule. And one gentleman was taking this. It went up to a furlong, up to a kilometer and so on. So the birth of a new fiber was the accidental discovery. And again the mind should be open, smart to find out this. Next. And similarly the celluloid, the one that was initially used to make what? The celluloid film, the moving film, motion film, all this was there. And the same celluloid was also used to make the new balls, croquet balls, this and that. And that was also accidentally discovered. Next. Now, one more compound, the saccharin we could call it, the artificial sweetening agents. There are some 4 or 5 sweetening agents which were discovered accidentally. Now, he was doing, what is the name of the scientist? Paul. Normally, coal is a byproduct of your petroleum industry. The natural petroleum is very hard, viscous, brownish liquid. And you have so many oils, middle oil, this and that, and you have so many fractions. You have kerosene, diesel, this and that. And one of the products is your coal tar. And he was doing some experiments with this. Now, normally, this is rich in containing aromatic compounds and so many other compounds. Now, one such compound was saccharin, which was found there. And he was doing some experiments. Because it came late, his wife called him, "Why you are not coming?" She was, so very thirsty, hungry. So he goes straight into the kitchen. His wife has made some karam, okay? He was eating. Not knowing what it is, he was eating. And he said, "The sweet is very good." She said, "What nonsense you are talking? I have made a karam, you are saying it is a sweet." And he said again another one he did. It was also tasting good. "Hey fool, it is sweet," he said. And she said, she ate, "Oh, nothing." Then he realized his brain was very smart. When she is taking it as karam, why it is sweet for me? He started thinking over this. He said, the difference between her hands and my hands are the black. He started dissolving this and he started testing and he got some crystals of sand. Artificial sugar for the sugar patients. Next. And this is one small example of an inorganic compound. When should I stop? You tell me. Because I don't find time. I don't look at my watch. I look at only your face. The moment I see some sadness, I stop. Okay? Because I have given such lectures thousands of times. So, I don't look at watches. Your face is the watch for me. Apati nalage? Yes, sir. So, Mogatala watch is me. Anyway, maybe 5 more minutes I can take or 10 more minutes? 5 more minutes. This side 5 minutes. This side 3 minutes? Any amount of time? We will settle for whichever is the highest. In add potassium peroxide or peroxide, you get some brown color or blue color. And the blue color is the one called as Prussian blue. Remember, this was a dye in those days. Normally the dyes will be organic in nature. But this was the first time an inorganic compound was made as a dye. Okay? Something like your ultramarine, this is a dye. How this was made? People were doing some experiments with cooking oil, and this was added with iron sulfate and potassium carbonate. They were trying to make a red lake. A red dye they were trying to make with organic compound. But in this process, once he added this and heated, he got a pale red color. See, the idea is, I want to make a color which is red like this. But what I got was a color like his shirt, very pale. So he was very sad. Oh, what on earth? I am trying to get a dark color, but what I am getting on earth is a pale red color, something like an yellow color. So he was trying to heat this. While heating, the ferrous became ferrite, and there was some ferrocyanide found there because there was some cyanide also there. Cyanide was there in the organic dye, remember. So he was able to make what? Ferrocyanide. The dark blue dye was born. Therefore, they were able to quickly recognize the presence of a new molecule. They isolated this, they studied this, they found that it was purely inorganic. So this is the first case of inorganic serendipity, I will call it, the Prussian blue. And there was a patent. People use this as industry because sometimes when you don't get the organic molecules, you can always get iron. Iron is very cheap, and ferrocyanide you can easily make from carbon and nitrogen. Next one. And the indigo, of course, was made in a serendipitous way because they were doing some experiments with naphthalene, silicon, hydrogen, and so on. The moment mercury was added, which acted as a catalyst, I was able to get this dye. Next, I think we can go. These are some of the examples in which some new things were discovered, like antiproton, because here was an experiment in which H2 plus, that is protonated hydrogen atom it is called, or H2 plus, that is hydrogen ion. And during this experiment, they were able to get what is called as a new compound called the antiproton. Next. Similarly, noble gases were discovered by so many people, and that was also quite an accident. And they were able to get new compounds, like by combining your fluorine, bromine, iodine with your noble gases, xenon, radon, and so on. They got new compounds. Because noble gases, you say they are noble, less reactive. But here was an experiment in which accidentally they made some new compounds. Somebody was doing some experiment with xenon, and xenon oxide, oxy compounds were discovered serendipitously. Fluoroxenon compounds were also made serendipitously in the inorganic lab. So these are all some of the examples. Next. And helium, of course, next. Hydrated electron, of course, was discovered like this because normally when you irradiate water, you get sometimes a blue color there. The blue color is due to what? An electron surrounded by water molecules called hydrated water. Copper sulfate, when hydrated, you get copper sulfate 5 water, the blue color you get. If you remove water, it becomes white. Remember, this is a test for testing presence of water. At one time, my student said, "Sir, I don't have anything to test the presence of water." I asked him, "Do you have copper sulfate?" "Yes." "Take it in a test tube, heat strongly, all water goes out, up to 200, 250 and so on. It becomes a white powder. Now put it there in the substance. If it turns blue immediately, there is water." Such is the power of this anhydrous copper sulfate, which takes up to 1 and some acetaldehyde. He was thinking, what could be the reason behind? Thus was born the optical activity. The structure was easily evaluated. See again, the inquisitive mind, the prepared mind is able to make new discoveries, just like that. Next, please. Okay, sweeteners, some of the other examples, cyclamate and so on. Sucralose, yes. Again, glass was made in those days accidentally because people were moving in ships. Well, they were in a shore. They didn't have any. They were trying to cook. While cooking was there, no rock was there. So they had some materials there. They took it and they heated. And it melted. and it combined with the sand wave, it was very shiny. So what do you get? This is a silicon material like clay material, and there was sand wave, glasses, mirrors, and so on. Next. And iron, of course, was made what? Accidentally like this. Next. Nitrous oxide, Davy, Tamil Davy, who was able to discover so many things just like that, For them, it was a habit to discover, because they had the smart mind. Even today you can make things discover. Don't say that, sorry, it is not saturated. No, never. And the nitrous oxide was there, and he had some pain. Because in those days, as I told you, you have to test it on yourselves. He was inhaling, he was laughing at the end. But initially his pain was gone. So it was an anesthetic molecule. Next. Chemical imagination, you might have heard about the organic aromatic structure. Initially people were wondering about the molecular formula because there was some loss of 2 hydrogen. They were not able to find out what could be the structure. But in his imagination, while he was dosing, the snake biting its own tail. Again, serendipitous discovery. Next. Again, the spindle, if you go to a textile mill, the threads will be twined. Twined one, accidental discovery. Because there was accidentally, some people were playing, some children, and it was spinning. Next. Matchstick again, accidental discovery. Next. Radioactive again, Ramjan. What is very important is, if you take sugar, it gives more calories, and directly it is harming. But if the structure of saccharine is different, it is not going to give you the same amount of calorie. Okay? And insulin is not required. Unless insulin is there, if pancreas was removed for a dog. Okay? The dog was urinating. After some time, the scientist was finding a lot of bees there. They were sticking on to that because there was glucose there or sugar there, sucrose. And thus was the scientific discovery that pancreas is required for what? Giving insulin, which is required for the digestion of this. So the absence of this, the insulin is not required for saccharine. And another thing is it is cheaper. Another thing is, even if you put in small quantities, the sweetening is 1,000 times more. In place of 1 gram, I can put a small pinch, sufficient. That is the beauty of that.
Combine the form of nucleus. And the electron, nucleus உள்ள இருக்குது. அது மட்டும் nucleus சுத்தி வந்துருக்கு.
சொல்றேன். Now he is talking about fundamental. என்ன இருக்கும் பாரு? You learn charges. Hydrogen bonding பார்த்தீங்கன்னா there will be a delta plus on hydrogen. ஒரு electron negative ஆகிறதுக்கிட்ட என்ன வருது? ஒரு H plus வருது. So, all forces in nature are originating from electrostatic in what? What we call as bonding, electrostatic bonding. So, nature must have charge separation. Charge separation இல்லைனா bonding இல்லை. அப்போ matter இல்லை. உலகம் இல்லை, நீ இல்லை, நான் இல்லை, எதுவுமே இல்லை. Therefore, God has designed in such a way that materials should be stable. There may be less stable, more stable, highly stable materials, but there should be stability. And for that, you must have charges, plus and minus, living together. நமக்குள்ளேயே நல்லவன் இருக்கான், கெட்டவன் இருக்கானா, ஆண் இருக்கான், பெண் இருக்கானா, இயற்கை அப்படிதான் வச்சிருக்கும். அப்பதான் அந்த சொசைட்டி ஸ்டேபிளா இருக்கு. So in order to have a stable atom, stable molecules, stable structures, you need to have charges together. Now, the moment I put an electron into the nucleus, what happens? நீங்க படிச்சிருப்பீங்க, K electron captured by the government of Tamil Nadu. He has held membership in councils, committees, boards and panels, various councils, committees, boards and panels, and he has a huge amount of research. He has the US Fulbright Fellow during October 1990, January 1997, and has visited University in Illinois at Urbana-Champaign, USA. He is a life member of Indian chapter of the International Center for Theoretical Physics, Italy.
He is a visiting scientist, guest scientist in reputed research institutes and universities in USA, Italy, France, Germany, in Indian Academy of Sciences from 2000 to 2006. He has been a member of organizing committees of national, international scientific conferences, workshops, schools, etc. for more than 15 years. He has a research collaboration with experts in non-linear dynamics in India and abroad from 1983 to till date. He has been the visitor under the Theoretical Physics Seminar Circuit of DST for giving lectures on advanced topics and recent trends in theoretical physics in different institutions in India from 1990. And he has various academic credits, of which I will list out a few. His areas of research include non-linear UE and was selected specially for publication in Virtual Journal of Biological Physics Research. He has been listed among the 200 researchers worldwide in the Who's Who of Physics of Life by L.C. Fine Coupling. He has been selected to visit various laboratories in Soviet Union during the period of 1992-93 under the Indo-USSR Cultural Exchange Program. And he has he has authored 3 books and he has more than 645 citations to his credit. And finally, he has research collaborations all over the world, that is in institutes and universities at USA, Germany, Japan, Kazakhstan, France, and he has visited almost all countries all over the world. I have in my hand a very vast CV. Due to time constraint, I am just putting it in a few words. And I request all of you to give him a vast round of applause.
And other distinguished faculty members of this prestigious institution and my beloved young students. It's indeed a great pleasure and privilege to be in this institution for one more time, and in particular for giving a lecture on this DST Inspire program. So one of the very interesting program proposed by the Department of Science and